All right. Yeah, we are live. So, good morning, Pawan, and thanks a lot for again being on the webinar series.
My
It's a pleasure
pleasure.
to talk to you every time because like you bring out so many interesting subjects, and they're always interesting for me as well. And today we have one of the things that I personally has been doing for a long time, but it always amazes me that how many things you can do with QGIS. It's truly amazing, and it takes out a lot of pressure also from trying to build everything from scratch. Last time I talked about something similar was on another podcast with the goat person Ujjwal Gandhi, and that was an eye opener for me. Like you can do so many things with QGIS that it's not just limited to a QGIS being a software, but you can consider it as a full stack thing where you can actually outsource the functions of QGIS and then use it in your own script. So for the viewers, I would like to tell you that if someone tells you that QGIS is just for you to drag the file and then make it look beautiful, it's not that all. It's tip of an
It's more
iceberg.
than
There are so many things that you can do with it. So Pawan is here with us again with an interesting topic, and we are ready to be amazed. So Pawan, if you wanna go ahead and share the screen, feel free
yeah.
to do so.
Yeah, thanks. Thanks for the introduction. And you're pretty correct. I mean, the QGIS is now a tool where you can use for analysis. And I think Ujjwal Gandhi sir, sorry, also said the same thing that they have a processing toolbox which you
Yeah,
can use for those analysis
yeah.
functions. But before the analysis functions, we need to understand what really is the topic that we are going to do. So, the topic here is about spatial analysis, right? And yeah, so what is it all about and why do we need it? So, in GIS, I think we now know that there are two types of data models. One is the raster type of data model,
I'm sorry to I'm sorry to interrupt you. Can you just click on that hide button?
yeah,
Because
I know.
like that. Yeah, perfect,
Yeah.
perfect. Now you can just go ahead.
Yes. Thanks a lot. So,
I think one more time. You have to do that
in
hide button one more
GIS,
time.
yeah, I know. This keeps coming. So,
Yeah.
yeah, now I'll go back to
Ah,
it. Yeah.
okay. There is no way around. Oh, okay. Perfect. Yes. Please go ahead.
No, the way I did it.
Yeah.
Okay. So, in GIS, there are two types of data models, which we now know, which is the vector data model, which is a representation of data in point, line, and polygon features, also known as um, point, polyline, and polygon. That's what we call it. And then we also have a raster data, which is made up of a series of pixels in the form of tessellations, right, or stellations. Now, within vector data, one interesting element that you can do is spatial analysis. So, spatial analysis is the ability to generate a new data altogether. And that is why it has become very popular. And it is more so popular in QGIS as much as it is in ARC and S3 based softwares. So essentially, spatial analysis uses spatial information. So it's not only location based information. I think this is a very beautiful piece of example, which is a tailor made example for all the students. So here we have multiple thematic layers. We have the land parcel layer, the land cover zoning layer, topographic layer, wetlands layer, and then we have also the satellite imagery and the base map. So all of them are combined together, yeah. And then once you overlay them, you extract a new information which you should see for your tailor-made requirements, right? So that is the power of spatial analysis. So it is a tool which uses spatial information to extract new and additional meaning to the GIS data. So there are three types of spatial analysis, or two main types of spatial analysis we deal with. One is buffering, and the other one is overlay. Now, buffering is a very interesting feature because the term has been used in many elements of life. There's a very important political element, but in GIS, in simple words, buffering creates two areas. One area which is within the distance, yeah, of the real world feature, and the other area which is beyond. Some people like to use the word transition zone. That's pretty weird, but it can also be the case. But to understand buffering, we sadly have to go into a more of a political dimension out here. So here, what you see is a representation of a real world buffer zone. This is the United States of America and Mexico border. And you can exactly see that this area is the wall, right? Now, there are two areas. These two roads are very important because they are the transition zone. And if you go towards the right of this area, you head towards United States. And if you go to the left of this area, you head towards Mexico. And this area, what you see out here, the road, is basically the buffer where all the law enforcement of both countries operate, right? So it serves a purpose of keeping real world features distance from one another, right? So this is in a political context, but you can use it in environmental context a lot. So you can use it for to know a corridor or a buffer zone, which is a transition between a city and a wildlife, right? We don't want city and wildlife to mix. As you know what happens in India, it happens a lot. So a buffer zone is very important. It's not only for GIS professionals, but it's also for urban planning. And GIS can help. It's a technology and tool that can help in facilitating a buffer zone, right? So here we have some types of buffer zone. The first type of buffer zone is a point buffer zone. So imagine that is a shopping complex, and you want to know the radial or the radius of coverage area. You can use this buffer zone, right? You can create a circular buffer zone and use it. But these are for the point-based features. It can be for a retail store, a hospital amenity, a fire station, etc. But for a linear vector feature, like a river, for example, we'll see in the next slide, or for a railway area or so forth, we have these line buffers which are there, right? Which are around a vector polyline. And finally, we have a polygon buffer. Yeah. And this is the area of interest. So let's say that this can be a nuclear station, right? So you want to have a transition zone between a nuclear station and civilian areas. You can create a buffer zone around a nuclear area or an industrial area for that matter, right? So within this, you can understand the variations of buffering. So we talked about the polyline buffer zone. So here's an example of three rivers that we can see and the cultivation around it, right? So here you can see the rivers are the Breed River, the Komati River, Orania River, and Tele River. Now, for the Breed River, which is this one, you can see that the cultivation is vegetable cultivation, intensive vegetable cultivation. So a farmer, right, or even a planner, or a regional planner, have to ensure that there is a buffer zone of 100 meters between this river and, more importantly, the cultivation area. So if this is the cultivation area, there have to be a 100 meter buffer between this river channel and the area, cultivation area, because this is intensive vegetable cultivation, and the farmer will risk a lot of problems if he has the vegetable cultivation near to the river. So he has to maintain the buffer zone. They have to maintain, in fact, right? But that's not the case for other kinds of agriculture activities. Like, for example, you can see the Orania and the Teli River. So this is the Orania River. Here you can see there's only organic farming that takes place. So you can reduce the buffer distance by 50 meters. So if a person wants to practice organic farming, he can practice in these areas. Unlike the intensive vegetable cultivator who can't practice it out here. So yes, Accordingly, the thing is set. So this could be for the Komati. Komati is cotton cultivation. So this probably will be Komati with 150 meters. This probably may be breed with 100 meters, and this will be the Tele River, which is only 50. So this is the idea behind this. The idea behind this is to ensure that a distance is maintained between the cultivation and the river channel which is there. So so that the agriculture lands aren't inundated at the time of floods. That's as simple as that. Then we also have a multiple ring buffer, and out here it's a very good concept if you have an industrial plant. So if somebody works in an industrial plant and wants to evacuate from there, he will have a buffer for 10 meters, 10 minutes, or 10 kilometers, 15 kilometers, 25 kilometers, and 30 kilometers buffer. And that will be the evacuation plan. And that depends also. If he is working in a nuclear or anything related to radioactive materials, then he should be somewhere out here when some tragedy takes place. But how does he know the distance? It's by creating these so-called multiple ring buffers that we have, right? So buffers can either be with intact or they can be with dissolved boundaries. So here we have an example of a buffer with dissolved boundaries, right? On the other end, when you can see the borders or the overlapping areas, there you can understand that the buffer remains intact. So that is another way of understanding it. Yeah. So I'll just pause here because they are very highly conceptual, and I'll see any questions you have. Are there any questions? I guess I don't see anything on the chat. Krishna, if there are any questions, Krishna sir?
Not for now. We can continue.
Okay. So if you understood the concept of a buffer, just give me a minute. I'll remove the height thing again. There you go. So now if you understood the concept of a buffer, the next kind of spatial analysis technique is an overlay. Now the overlay, as you can see, it defines a spatial relationship, right? And it identifies a spatial relationship between two polygon features. And it altogether creates an output which is a totally different data, right? Within overlay, spatial overlay, we have four types of overlays which are present. The first is intersection. The second is union. The third is symmetrical difference. And the fourth is difference. So by looking into this geometry itself, I think we understand what this overlay is all about. So an intersection is an element where, let's say the circle meets the square. It's the only overlapping areas which will be the output. Union is the whole thing. Symmetrical is the difference which will only be executed as the output. And when there's no overlay, right, then you can clearly see a clear-cut difference which will retain the properties of both features and output. So we'll go into it step by step. Intersection. So the output layer, okay, let's just go first by the words of it, and then I'll give you the geometric explanation. The output layer contains all the areas where both layers overlap and intersect. So let's see an example here. This is a rectangle, right? And this is one input. This is a circle. This is another input, right? Now, if you really look into this output, it is only the D area, what I call as a D area, or the semicircle area, which is intersected feature. Now, that intersected feature will be the new output that you have. So such kind of operations would be known as, or would be called as, intersection. Here's another nice example. There's a nice triangle, blue triangle, and a nice colored circle. You can see the green area that I have put out is the area which is intersecting, or which will be your eventual output. Then we have union, right? And here you can see the output layers contains all the areas of the input layers combined. Yeah. So that was in words, but let's just see how the geometry works. So this whole square or rectangle is combined with this whole circular area. The output will be the whole thing. There will be the whole area of the square or rectangle and the whole circular area too. That is the aspect of a union, right? Because the data generated will be the aspect of a union. Yeah. So again, a nice geometric example. Here you can see is a rectangle, a grayish rectangle, and a blue circle. The output will be the whole rectangle and the whole circular area. So this will be the output. So it's considering the whole area as a whole as the output. Now that kind of operation is known as a union. Then we have a symmetrical difference where the layer contains all the areas of the input except this area, which is highlighted, or these areas which overlap and intersect. So you can see the eventual output. This is how it is. So you can clearly see these. This area is intersected, and then the output will be the area which is having a difference. Yeah. And finally, we have a difference, which is the output layer contains all the areas of the input layer which do not overlap, right? So here you can see an example. This is a rectangle, a circle, and then the eventual output will be this rectangle will be a different layer or a different geometry, and this circle will be a different geometry. And that is the difference. Here, the difference was that it will not consider this red area, it will only consider these two blue areas out here. Here, the difference is it will consider the area which the whole area which is merged, but it will retain its own geometric properties, right? Here, it doesn't retain its own geometric properties. That is the difference, symmetrical difference and difference. So, having understood all of this, I think we can do a quiz, but I think there's nobody for this. So, yeah, so I'll end my presentation of spatial analysis and see any questions. And then we can go forward doing a small tutorial. Yeah.
Yeah,
So,
no
Krishna,
questions for
over
now.
to
Yes,
you if there are any questions,
yes.
anything.
No questions for now. We can continue. Thank you.
Yeah, yeah. So, I think I'll do a small presentation. So,
Hello.
yeah,
Yeah, great.
we can do a small
So,
tutorial. So,
sure. If you want to share the screen, please go ahead.
yeah. I'll share my screen. So I'll share my screen out here. And so a small tutorial of how this is done. So I have a presentation, which I think I have it out here. It's how a simple vector analysis is done. And this is my Miss Ulema. Yeah. So if anybody wants to practice, I can give them the tutorial link on the chat itself. Yeah. So you can go ahead and practice this. So the first thing that we do is we download the data. So here you have a segment of downloading data. If I can share my screen, yeah, it's shared. You have vector styling. This tutorial is a continuation of vector styling, but now we are going to do analysis. So the first thing that we are going to do is we are going to download the data. So we can first download the country's data set. Yeah, that you can download it. So you have a country's data set shapefile, which will be downloaded out here. Yeah, and this you can get it from Natural Earth. Yeah, and then we'll come to this tutorial of vector styling and download this data. Yeah, which is the World Heritage Sites, and we'll also download the vector styling zip file. And this comes in a CSV file format. So now I'll start with my new project. Yeah. And once I start with my new project, I will go first to my D drive. So, or my downloaded area. So I have a downloaded area out here somewhere. I can go to my downloaded area or documents and so forth. You have a downloaded segment also where you can go. So give me a moment. I'll just go to the downloaded area which I have, or I'll just see whether it's downloaded or not, or I'll just go to my computer, this PC, or yeah, somewhere in this PC it should be there. Yeah. Yeah, this is, or I'll just come here, and or I'll just go to any file folder here. Yeah, and I'll click on downloads where it is currently there, the data. Yeah. So it should be downloaded somewhere. Let me just check. Yeah, this is the place where it's downloaded. Good. After doing that, my next procedure is to copy these two files. Yeah. And here you can see you have the option of copying. You copy it. Then the next thing, which is the best practice, is to create a folder on the your local drive or your local disk. Yeah. And here I will go to folder and I will call this as vector spatial analysis. Yeah. Once I do that, I'll come here, I'll copy paste these two documents that I have. Yeah. And then I'll click on this document or this folder and I'll just press extract all. Right. And you can see that this is extracted. Yeah. After that, what I'll do is I will get this data on my local or on my QGIS. I'll drag and drop this data. For that, what I need to do is I will go to my D drive, yeah, where it is, where I've saved the data. I'll see whether vector spatial analysis is there or not. I can also refresh this to see whether it's there. It's there. And I will drag and drop all these country shape files that I downloaded. Yeah, so all the country shape files is there. After that, what I will do is I will then go ahead and upload the point data. Yeah. Now, what we need to do, we need to understand this. We need to project the World Heritage Sites, right? So the World Heritage Sites all around the world, we need to project it. After projecting it, we are going to do two steps. One step is to, one step is to do a spatial query, which we are going to do using the processing toolbox. The other step which we are going to do after that is to create a heat map out of it, and that's the symbolization that we need to do. So this is what we did currently. Now, in order to get those point-based data of all the World Heritage Sites, we are going to come to the Open Data Source Manager. Once we come to the Open Source Data Manager, we'll come to delimited text. Once you come to delimited text, and delimited text feature within the Data Source Manager will take all your CSV files that you have. Once you do that, you come to Vector Spatial Analysis, go to WH Sites 2021, open that. It's all in CSV file format. Yeah. And we can add it if you have the data that is there. Yeah. Yeah. And now you can see the points or the World Heritage Sites are added. Yeah. The next thing that we need to do is we are now going to use a spatial analysis tool called spatial query. In order to do that, we go to the processing toolbox. The processing toolbox is this area. Within the processing tab, we have a toolbox which is in a screw, right? We click on that. Yeah. After we click on that, we will use a command, and the command is to extract tool. We'll use the extract tool, yeah, and do that. So we will use the extract tool, but before we do that, there are other two things that we need to do. The first thing is how we reproject this. So they want it to be reprojected in a Winkle based projection. In order first to do so, we come to this area. Yeah, we can also use, we come to processing toolbox. We can also use the tool of reproject. Yeah, we can use this tool. But now what I want to do is I can come here directly for now, and I can change this current CRS that I have. Yeah, or we'll click on this layer, change the current CRS to Winkle, right? So we have this one, the 5 EPSG, they have a EPSG code, which is 54019. So we'll click on this one, apply it, and you can see the projection itself is changed, right? Because this is the projection the tutorial wants me to do. That's why I'm doing it. So this is done. So it is always very important to reproject your data. Why? Is because every country wants to see the representation differently. But that comes under map projection, though. That's a different topic. But for now, I've reprojected it this way. Doing that, I will use this tool of selecting a feature by area. I'll select a feature and I will click on United States, because we want to see how many World Heritage sites are there within the country of United States of America. That is what we did. Now we'll start the processing tool, and then we'll go to a tool called extract. Yeah. And what we have to do this time, according to the tutorial, we have to use extract by location tool, right? By location, this tool we have to use. It comes under vector selection. Click on that, and then you have the following details that you have to fill. So what you want to extract is you want to extract the World Heritage Sites layer, which is there. There you want to extract it. Which tool you want to use? You want to use the intersection tool, okay. And then after that, you want to compare features, and you compare features. Click on this, and you want to compare features by select features only, right? After doing that, you can put it at a location. So I would say that you can save it as a geo package layer. Come to this area, and we will go to vector spatial analysis, and we will call this as WHC dot GPKG, which is the file extension of GeoPackage. Save it and call this as World Heritage, and that's underscore US, because we're only dealing with America. And then we can run this tool. So now the output that you get is something like this. It only shows the World Heritage Sites which is within United States of America. So this tool is called using spatial query, and we have used the vector selection, and we have extracted by location. So that is one thing that we have done successfully. So you only see the American, you can see within, so it's within an area, it's a within tool. So within United States, you can exactly observe the World Heritage Sites that are there. So that is one thing that you can do using spatial analysis. And then finally, you can visualize it through a heat map, right? So now I'll off this tool. I will clear the selection. In order to clear the selection, you have to deselect all layers. Yeah. And in order, now I'll come back to the World Heritage Sites. In order to project this as a heat map, what we do is we come to the layer styling panel. Yeah. There's a single symbol that we have. And instead of that, we'll go to a heat map. Yeah. In the heat map, we will put magma. Yeah. So that's what we like. And then we can visualize it. And then we can apply the area, the heat map that we have. So sometimes we can, or we can actually use the heat map. Yes. And yeah, let me just go back to the selection. Just give me a minute. This is the color ramp heat map. We'll go for we'll first go for the single symbol first, which is out here. Yeah, and then within this marker, I think we can do a heat map out of this, and then we can just take it to the radius 2. We can put it to 2. Yeah, and then we can go for magma, and let's just apply it to see whether it happens. Sometimes it does, sometimes it doesn't. Yeah, so that is one way to visualize it. So through heat map, you can visualize it. Right, so or you can visualize this, or you can just click on this layer and visualize it. Yeah, so go to heat map. Yeah, there we can visualize this. We go to magma. Yeah, and we get it to radius to 2. Yeah, apply it, and then what we can do is we can just put this on top. Yeah, and we can now come to layers symbolization. And now we'll go to the admin areas. Yeah. And what we can do now is we can put a transparent color. So you have an option of putting a transparent color also. Yeah. So you can click on simple fill, and we can put a transparent fill out here. So in a transparent fill, you can overlay this heat map on this, and you can see the borders. So you can see here the maximum distribution of through this heat map, you can see the maximum distribution of World Heritage Sites is in either in UK or in Central Europe, right? That is what you can get to see. And areas around India and Sri Lanka also. There are a lot of World Heritage Sites in North India here. In Mumbai also there is, but in most other parts of India, I don't see much of them. They are sporadically distributed. Yeah. So same with China and other countries of the world. So this is a great way of visualizing. This tool is a very great way of visualizing, right? But other than that, these are the simple techniques of how spatial analysis is used, right? So yeah, so that is it. So that was my presentation, and that was my topic for today. So over to you, Krishna. Any questions? Let me know.
Yeah, yeah. Great presentation, first of all. There is one question that I see. I'll just bring it on the chat. And that's like the variable buffer distance will be based on attribute values or like feature types.
Um, it depends. I would say it can either be, sometimes it can be features, or sometimes it can be attributes. So the buffer distance is based on the feature, right? So either it can be a polygon feature, a point feature, or a line feature. So it's entirely based on that. Attribute values, I'm not too sure, but it's entirely based on the features that are there. So, like for example, I think I'll just share my slide, which I wanted to show you. So we'll come back to this slide here, right? Just let me share my screen again. Share my screen. Yeah. Entire screen. Yeah. So here you have an example where I think this thing. So here you have a very good example. This is one example. So what are the features? Either the point feature, the line feature, or the polygon feature, right? But to give you a good example, here you can see this is the river, right? And the buffer distance sometimes can be, in this case, they have gone by what is cultivated out here, right? But you're basically buffering, or you're doing the buffering from the river itself, right? So you're doing your buffering from the feature, which is the river. You're not doing it by an attribute. But the reason for what you're doing is because there is a cotton cultivation out here. This is the river Komati. I think this is the river Komati, or this area is the river Komati. And since there's a cotton cultivation out here, you're basically doing the buffer. But on what you're doing the buffer, it is the river feature, right? So that is the most important thing. You're doing the buffer on the river feature. And that is the most important thing you should know. Attributes, not too sure whether you do that, but most cases, buffering is done on the respected features that are there. So that is the best example I can give you.
Yes,
So I hope
I
that clears
yes,
Dinesh's question. I think Dinesh Patil asked that question. So I hope
yes.
it clears his
I
question.
think that's all we have for now. And thanks a lot again for doing
Thank
this.
you,
It
Krishna.
was
Yeah.
interesting for someone who is starting up, just like taking up QGIS and wants to do more than just like cartographic work. If they want to understand how analysis, like how we can do analysis as well, and use the power of Python and GDAL combined in the QGIS, this can be a very good starting point.
So you
uh,
can do that also. You have, I think you have a console called as
yeah.
it's called as a Python console. So for people who are not liking the mouse, you can do the typing work on Python
Yes.
too. So that is a script work
or,
that you
or
can do. So
generally,
I,
if you're
I,
sitting
I
with
trained
your
myself as a classic geographer. I never trained myself as a programmer. That's something I'm training on.
Yeah.
Yeah.
No, so like, yeah, if you're sitting with your friends and you want to just show off, then you can just simply omit the mouse and do everything with keyboard. At least that's what I do in order to show them that, yeah, I'm not just having fun, I'm doing some serious work as well. So thanks a lot for taking time off.
Thank you,
We
sir. Thank you,
have a
Krishna,
couple
sir.
of
Yeah.
minutes. If there is any question, I'll pop it up to you. And anyways, like I see you're quite active on the GeoBharat Telegram channel as well. So if someone wants to connect with you afterwards, I'm pretty sure like
Yeah.
they can just
So
drop a
I
message.
just want to publicize the next program that we have at GRED
Yeah,
Foundation. So
yeah,
I'm working for two organizations now. One is GRED Foundation, and GRED Foundation is going to have first, I think I come to this. GRED Foundation will have a disaster management program where you learn QGIS applications and many more applications, right? So it's going to start on 15th April. There's still 8 days left. And we have been doing good in these courses. We have got good recommendations. And this is one institute where I want others to come into and try. We're also making a new portal like Udemy where we can upload all the, if any instructor wants to upload his presentations, he can do that, right? That is one
nice.
thing.
That's
And
interesting.
so I'll just stop my screen. Another thing that I want to say is we are doing a lot of humanitarian mapping work, and that is one aspect. And now there are two major earthquakes that are taking place. I'll
Yeah,
just come to that 1 second. So there's one earthquake. So I'll just present the screen out here. And so there's one earthquake which is happening in so there's one earthquake which is happening in Papua New Guinea, where you can map. So this is another way that you can train yourself, right, in mapping. This you can do hardcore mapping right from the beginning. So here
this
it's taking
this
place.
I would
Yeah,
highly
I'll give you the
recommend
link.
everyone. I would highly recommend everyone, like if you are looking to get into the open source scene, I think like doing something like this can be a very good way for you to get started, because it will
Yeah.
definitely help you to increase your confidence that, yeah, like I can also contribute. And at the same time, people like Pawan are always there to help you out, even if you have like a
Yeah.
very basic doubts as well. So I would highly recommend everyone who are using open source softwares for a long time. This can be a very good way where you can start contributing even if you don't know programming side of it. Yes.
Yes, yes, yes. This is a great way, in fact, because and you're doing it for a good cause, and you'll
Yeah.
enhance your mapping skills. So OpenStreetMap has paved the way, especially its humanitarian significance. So the other one was Papua New Guinea. This is another main important emergency mapping that's going on in Taiwan, right? So you can learn, you can map at least one grid out of this. A lot of, I mean, in GeoBharat, I demonstrated how you can use
Yes.
OpenStreetMap. I think that is there on YouTube. So if these two also can be done on the tasking manager, it will be of a great help. So these two tasks I can put forward to you guys on my
I guess
private chat.
I think you can put it on Telegram as well. People would be very much
Yes,
interested into
yes,
this.
yes,
Yes.
yes. Yeah, this is one task, and this is the task that is taking place in Thailand. So, more about this, you can contact me. And if, in case you want to request training in this, I'm now an OpenStreetMap guru. So, we with the Asia Pacific hub, since we come under that region, that priority region, we can go ahead and do that. Yeah, definitely. Yeah, yeah. Thanks for a good cause. You help someone in this. That's it.
Yes. Nice. It was great talking to you, Pawan, and I hope I
Thanks a
will
lot,
meet
Krishna.
you again soon with interesting topics like this. So
Sure.
yeah, thank
Definitely,
you.
definitely. Keep it alive.
Have a great
Keep
have a
the
great
Josh.
weekend. Yeah. Bye. Bye. Thank you
Bye. See
everyone
you,
for
Krishna.
attending.
Take care.
Bye.
Yeah.